All right, so last time we were looking at exponents. Remember that we were trying to solve exponential functions or exponential equations where we were trying to find out what x was. All right, so we're going to continue on with some of that, although we're going to change gears a little bit today. Remember, exponential functions are functions where x is in the exponent. It's not like x squared, it's more like 2 to the x power. So something we didn't get to last time was factoring using exponential equations. See if we can fix the light. Yeah, that's better. Okay, so we've practiced factoring using x squared equations, but we definitely haven't done this semester. So this is your goal when encountering any sort of factoring situation. You want to factor so that you can set each term to 0. Okay. Also remember, if I can spell remember, that if you were to set something like b to the x power equal to 0, you wouldn't be able to do that because in fact b to the x cannot be 0 unless b itself is 0. Okay. In other words, remember something to the 0 power is actually what instead of 0? 1, right? So there's no way to raise something to a power and have it be equal to 0 unless the base you were already starting with was 0. So 0 to any power is 0, but 2, for instance, to a power would never be 0. Okay. All right, so let's practice some of our factoring tricks, but expand it to exponentials. So let's say I asked you to solve the following. X times e to the negative x plus 7 times e to the negative x equals 0. Okay, so this looks really, really ugly. Remember, e is that number 2.718281828. It's not a variable. Okay, but what I hope you would see is, yes, this is ugly, but I think these two groups have something in common, right? What do they have in common? They have the e part in common, right? And if you were to divide the first group by e to the negative x, what would be remaining? What would be left over? X. And if you were to divide the second group by the same thing, what would be left over? 7. Okay, and then just like we do when we do traditional factoring, now we're going to set each part equal to 0, right? So we're going to say e to the negative x equals 0 and x plus 7 equals 0. But we already said this one can't happen. E to the negative x can never be 0. Okay, bless you. So this one has no solution. Okay, that piece has no solution. E to the x, no matter what we do, if we raise e to a power, it's never 0. Even e to the 0 power is still just 1. Okay, but we can solve this second one, right? So we can set this equal to 0, so it looks like x equals negative 7. Okay, so this is the only answer because the other answer was no solution. The other part of the problem didn't result in any tangible solution. Okay, so I'm going to see if this color will show up. Yeah, that color shows up fine. All right, so let's look at another one. So e to the 4x minus e equals 0. Now, if it wasn't equal to 0 ahead of time, what would you need to do? Set it equal to 0, yes? Okay. All right, so what do you notice is common in both things this time? At least an e, right? What's this understood to be power-wise? E to the what? E to the first, right? So I'm going to factor out an e But I'm going to have to think about what happens when I factor out an e from here. Okay, so maybe off to the side we're going to talk about this. So what would e to the 4x divided by e to the 1 be? Because that's essentially what I'm doing, right? We can even write it as e to the first if you'd rather see it like that. So what happens when we divide an exponential term by another exponential term? What are we supposed to do with the exponents? Subtract them. So this is e to the 4x minus 1. In other words, we don't know what 4x is, but because we're pulling out an e, we have one less than we started with. Okay, so this is going to be e to the 4x minus 1 power. And then when you divide e by itself, you get what number? 1. It doesn't go away, you just get 1. Okay, so I know that's strange, especially this part right here, but again, that's why I wanted you to work this over off to the side. Okay, so that would be kind of your side work. And then you'll set each part equal to 0, so e will be 0. And what else will be 0? Yeah, so the e to the 4x minus 1 and then minus 1 will also be 0. But we don't need to do any work with that because e is not 0, right? Like e can't be 0. E is not a variable. What's e equal to? 2.7 blah, blah, blah. So it'd be like setting a 3 equal to 0. It's not. Okay, it's not equal to 0, so we don't have to worry about that. But this one, we can do a little bit of work, and so let's go ahead and add 1 to both sides. Now, normally speaking, we wouldn't be able to do this quite yet. We're going to learn how to do that later on in the week. Okay, but hopefully you can remember that this is actually a special case. Okay, so you need to kind of ask yourself, what exponent gives an answer of 1? Okay, and we've already actually talked about that today. Okay, what exponent gives an answer of 1? 0. Okay, so in other words, we can kind of ignore the uglier parts of this. We just need to find when is 4x minus 1 equal to 0. Because if that whole exponent's equal to 0, then what will e to that thing be? It'll be 1, and then we'll have 1 minus 1, which is 0. Okay, so in other words, kind of like we did last time, we're ignoring the part that we already know about, and we're just focusing on the part we want to change, basically, or we want to figure out. So we're going to add 1 to both sides. So we'll have 4x equals 1. And then last but not least, we'll divide by what? 4. So in the end, we get a single answer of x equals 1/4. Okay, so I know that's strange, and I know we're probably not super comfortable using e yet. Okay, but remember, you can check these on your calculator, and so I didn't bring my calculator last time, so I want to show you what that looks like. Okay, so this is how you would check it. So before, notice all the buttons on the left-hand side, there's one that says E, but it's in blue, so you have to use the second button first. So I'm going to do second, and then notice I have an E, well, if it's not in the glare, notice I have an E to the power of, so I'm trying to check it with this original part, right? So I'm going to say 4 times, and then what did I think X was? 1 to the 4, or 1 over 4, I mean. Okay, so it's kind of hard to see if you're in the back, but that's 4 times 1 over 4, right? And then I'm going to get out of the exponent, and then I'm going to do minus e to the first power. Because notice, I'm just plugging it into this original, and what should I get if I did it right? I should get 0, okay? So you can kind of verify in that way that you do. So you're just checking to see, does the left side equal the right side or not, okay? Okay. So maybe one more, and then we're going to look at some applications of exponential functions that are really pretty highly covered in this class. All right, so what if I had I'm trying to think of what I want to do. 3 times 5 to the x power minus x times 5 to the x power. And let's say that that equals 0. So I wanted to make sure and show you one that it doesn't always have to be e. It could be any exponential function, and this is an exponential function because it's a base raised to an x power. So just like we did before, by the way, you would never, ever, ever multiply this 3 times 5. Okay, you're not allowed to do that because what are you supposed to do before multiplication? You're supposed to do exponents first, right? So think of these as buddies or a duo that can't be separated, okay? So you would never, ever, ever do 3 times 15. You're not allowed to do that. But you are allowed to say, hey, I think both of these things have a 5 to the x power in them, so I'm going to divide or factor that out. And then what would be remaining in each of the groups then? What about first group? 3. What about second group? X. And then once again, we would set each thing equal to 0. But what can we say about this guy? 5 to the x what? Never 0, right? And then what do we get here? Just be careful about the signs. If you move the 3 over, you'll still have a negative x, right? So what's actually x equal to in this one? X is 3. Okay, so it will always, in this section, be something like that, where you can pull out what they have in common and then use that 0 product property, which just says that if I have two things multiplying to give me 0, then one of them must have been 0. Okay, it cannot be that one, so it must be this one. Okay, so if you have your calculators, I want you to go ahead and get those out. We're going to do some activities where I'm going to want you to try to enter this stuff in your calculator with me. So we're going to talk a lot in this class about finance, personal finance, and kind of business finance. Okay, so the first thing that I want you to know is what compound interest is. Compound interest is essentially interest that grows exponentially. Okay, most of the financial world runs on compound interest. Okay, and so it's not just interest that stays steady. Interest that stays steady, just so you know, is called simple interest. And the name implies kind of what it is. It's simple interest is basically interest that remains unchanged through the life of the loan. So I'm going to give you some formulas for compound interest, and then we're going to compare these two types of interest because I want you to see kind of what the difference is. All right, so the first formula is for simple interest. So this would be like if Grandma gave you a loan and was going to charge you interest. Grandma probably wouldn't charge you compound interest. We're going to assume so anyway. So the formula for simple interest, and I'm going to say what all these variables stand for in a minute, is going to be A equals P times 1 plus the rate. Okay, so let's define what these are because we're going to be using these letters over and over. So P is the principal. Okay, another way to say this is the original amount. A is what we call the accumulated amount. I'm going to abbreviate that like that, but it's always the final amount. It's the amount in the account after interest has been added. What do you think R is? R is rate. Okay. The important thing to know is it's rate as a decimal. So how do we change percentages? Because usually our interest rates will be given to us as a percentage. So how do we change percentages to decimals? Move the decimal place how many times? 2. Okay. And then finally, we are going to have a time component. And so T is going to be the time. Almost always in finance situations, the time is in years.
There was a homework one that wasn't
Yeah, but we haven't done any finance. I'm saying in finance questions.
Oh, okay.
Yeah, in finance situations, we're almost always talking about years. So if it happened to be in months, you would change that to years. So if it was 6 months, you would use half a year for that. Okay, so we're going to adjust this simple interest formula in a minute, but I want to talk about compound interest. So there's two types of compound interest, and we're going to talk about the differences between them, so just write this down for now. For periodic compounding, periodic just means on a certain schedule. So periodic might mean yearly, it might mean monthly, it might mean weekly. But any sort of schedule is going to look like this. The formula is A equals P times 1 plus R over N to the NT power. Actually, this book, hang on, I forgot. This book uses the letter M here, so let's do that. Every other book I've seen actually uses the letter N. But we're going to try to match what the book says. Okay, so M is the only variable that we haven't talked about yet. And so M is going to be the number of times per year that interest is compounded. Okay, so before we move on to the next formula, and we are going to do some examples of these, don't worry. Okay, so if we were compounding monthly, what would M be if it were monthly? How many months are in a year? 12, right? If it were weekly, what would M be? 52. Glad y'all know that. Usually my previous students, they don't know how many weeks are in a year. You're going to need to know how many weeks are in a year for the finance unit, so there are 52 weeks in a year. What if it were daily? Then what would M be? How many days are in a year? 365. Okay, what if it was just annually, though? How many times a year would annually mean? Just once, right? So M is dependent on how many times a year the interest is being figured / compounded. And then the final one is for continuous compounding. And continuously compounding means the interest is kind of always being figured. I call this the PERT formula. Just make sure that you know that the R and T are actually in the exponent spot. Okay, so it's not all of them multiplied by each other. It's P times e to the RT power. Okay. So before we move on, I want to alter this simple interest formula because this is the formula if it were only 1 year. But most often our money is probably going to be invested for more than 1 year, so just add a T in there. It's actually 1 plus R times T if T is more than 1 year. Okay. So I want to look at a problem. I want to compare. We're going to try to stick with a really small investment. So we're going to compare a $100 investment at 10% interest compounded annually versus simple interest. Because I really want you to see kind of the snowball effect of compound interest and why it's important. Okay, so we're going to come up with a table, and so in the first column, let's do the simple interest calculations. In the second one, let's do compound interest. I chose annually because it's the easiest one to figure out. Okay, and so we're going to come up with a table, and then over here we're going to put the years. So we'll start with year 0, and let's go up maybe 5 years. What do I mean by year 0? Like to start off, yes. Okay, so you have notebook paper, so your table ought to be able to look prettier than mine. And so I chose 10% to demonstrate this because 10% is easy to figure out. But I'll just be honest, 10% is not a very common interest rate to get on your money. Okay, 10% is actually a really good interest rate. You never, ever will get that in a savings account. You won't even get that in like safe government investments. The only way you're getting 10% is to risk it on the stock market, and then what do you also have a risk of losing it, right? So just to be clear, 10% is not necessarily a realistic interest rate. But the reason I'm doing 10% is how easy is it to find 10% of something? Really easy, right? What do you do with the decimal place? Like you don't even need a calculator. You just move it once, okay? So let's start off. Both investments are worth $100 to start. Okay. All right, so let's do the simple interest formula first. Okay. At simple interest, they're going to earn 10% a year. So how many dollars is 10% of 100? $10. So they're earning an extra $10. So at the end of year 1, they're going to have $110. At the end of year 2, they're going to have what? 120, 130, 140, and then finally 150. Okay? Can you see why it's called simple interest? It's pretty what? Pretty simple. Okay? Where they're just earning the same amount every single time, easy peasy. Okay? But compounding is different from that. Okay? And I'm going to show you why, and maybe we don't even have to necessarily use the formula, okay? So here, after the first year, there's actually no change. You're going to take your $100 and you're going to add the extra $10 for a total of $110. Okay, so after year 1, the accounts are actually the same. But here is where it begins to change, okay? In the second year, they're going to take their $110 they have after year 1, but they're going to get to earn interest on the full 110, not just the original 100, okay? So what is 10% of this? Not of the original 100, but what's 10% of this? Again, we should be able to do it without a calculator because we're just moving the decimal place once, right? So how much extra dollars? 1, okay? Well, like 11, right? 1 extra dollar from the other situation. So now I have $121. Okay. So I know that might not seem like much, okay, but let's move on. So then in year 3, they're going to get their $121 from the previous year, but they're going to get an extra what now? If you move the decimal place once from 121, what will you get? An extra how much total? $12.10. Yes, we care about pennies, okay? And so that's going to be $133.10. Okay, so what happens in the 4th year then? They get to keep the what? They get to keep the $133.10, and they get to add an extra what if you move the decimal place? $13.31. Okay, so we'll do that on the calculator to make sure I don't mess that up. So $133.10 plus $13.31 is $146.41. So then last but not least, we have $146.41 plus what? So we're going to move the decimal place, and then we're going to make sure we cut it off or round it to be pennies, right? So how much would it be if you move that decimal place once? 1440 or 1464, right? So an extra 1464. So if I add 1464 to my previous answer, I get 161.05. Okay, so I know that might not seem like a lot, but clearly which account has the most money? The compounded annually. Do you see what's happening? That we're snowballing the extra we're putting in the account every year. So can you see that that would be way more powerful if you left the money for, say, 30 years? Okay. It'd also be way more powerful if you invested more money than $100, right? I was trying to keep the amount simple and nice. Okay. So compound interest is actually one of the most powerful forces in finance. Okay, that's how people, if you wonder, like, how are people having millions of dollars when they're just school teachers or whatever when they retire? This is how they're having enough money to retire. Okay, that's how they're doing it. That's how they're doing it on modest incomes. They're just saving for a long time. There's nothing magical about it. Okay, so kind of like losing weight, you know, there's no like shortcuts. You just got to buckle down and be responsible with it. So the sooner you can save, the more time you have for your money to snowball. That's why it's important to do it when you're young, not necessarily when you're older. Okay, so if I start, for instance, at my age saving, I don't have near as much compounding time as you do at, you know, in your low 20s or however old y'all are. So do you see what I mean? So it's actually really, really super powerful. Okay. All right. By the way, this process can work against you if you're borrowing money from someone, right? So that's kind of something to keep in mind too. So all of us will borrow money at some point, probably, right? Unless we're independently wealthy or our parents are just super generous. We're going to have to buy a car and we're going to have to buy a house and stuff like that. But we don't want our interest that we're paying to snowball like this, right? So these are things we need to be aware of when we go make purchases, okay? Okay, so go ahead and get your calculators out, but let's look at maybe some bigger investments, and we're going to use our formulas from above. So what if I asked you to find the value of $10,000 in 12 years if it earns 3.95% interest. That's a much more realistic interest rate, honestly, compounded continuously.
So that chart was just showing us it laid out the house.
Right. I just picked values we could do easily. So I was just trying to show you what compound interest is compared to simple interest. Okay. But yes, so we wouldn't do a chart like that for this problem. We would just go straight to the formula because we wouldn't want to make a 12-year chart, right? That would be tedious and unnecessary. Okay, so it is important that they use this term continuously. Okay, if they say continuously, then you're going to use that PERT formula that I mentioned above. Okay, remember that's P times E raised to the what? Rate times time power. Okay, so make sure we put in everything right. So where would the 10,000 go? Is the 10,000 the ending amount in the account, or is it the beginning amount in the account? It's the beginning, right? So we need to put it in for P. And then we have E, and then be careful about the interest rate. You don't put in 3.95 or you're figuring 395% interest, which is crazy and not really possible in most legal ventures, right? So what would be the decimal of 3.95%? It'd be 0.0395, right? And then you times it by the number of years the investment is staying, right? Which is what? 12? Okay, so there's no question about it. These are calculator questions. You've got to have a calculator. Now, you don't have to have a calculator like this. You don't have to have a graphing one, but you do need like a scientific one. So I've got a couple of scientific ones. Like if you don't want to go to the store and buy a graphing calculator, which I get, they're kind of expensive, but you can find scientific calculators like these. You just have to make sure that it has like the exponent keys. Well, you can't really see because it's too glary. But see how it has like exponent keys and stuff like right here? Okay, so this is about $11 or so, between $11 and $15 at Walmart. And so I really like this one. It's a TI-30XS, but you need some sort of scientific calculator. Now you can Google search scientific calculators, graphing calculators to get one to use at home, but it would just be better if you had like a handheld one where you could do your homework elsewhere and still have access to it. So, all right, so if you have a calculator, I want you to go ahead and enter this in with me so that we can make sure that you know how to do it when you get home. So you're going to do 10,000 and then times, and then here's where you put your E button. Okay, if you have an older calculator, keep in mind that your E may not look like mine, because notice my E has a flashing cursor at the exponent. If you don't have that, then you're going to have to use parentheses around your exponent, okay? And so that's going to be 0.0395, and then times 12. Okay. Always make sure you think your answer makes sense when it's done. In other words, this looks like we're getting $16,064.07. Okay, so how much extra is the account? It's an extra like $6,064 and so however much cents, right? So does anybody have a black TI-83 calculator I could borrow real quick? Okay, so can I use yours? I just want to show you what some of the online calculators look like. Oh wait, that's an 84. So I need like just a solid, like yours is basically too new. Does anybody have one? Like claim, no, that's still an 84. Actually, maybe. Let me check it out. Nope, yours is still too new. So, okay, I should have brought one, but honestly, I don't have one either.
I don't find the same way.
Yeah, I'll have to look at yours after you're the Casio, so I'll look at yours and tell you where the buttons are. The buttons are off, a little bit off on the Casio. But anyway, I almost always have a student that has one, but if you don't have it, then you're going to need to put parentheses around the exponent. So it'd be like this. So the older calculators will make it look like this, and then it'll open up. Oh, still this one is too new. Okay. So anyway, if you have an older calculator and it doesn't do this cursor thing, just do this right here. So notice, what did I put around the exponent? Parentheses. Okay, I don't technically need it for this calculator because, again, it's newer and it's opening up the exponent box. But if you have an older one, just put parentheses around it. Okay. If you don't, you're going to get an answer that doesn't seem reasonable. Okay. If you get an answer that is like 6 times what you started with, that's not reasonable, right? Like, no one gets investments like that. If we did, we'd all be investing a lot more money, right? So make sure your answer seems logical and not too crazy bigger. All right, so let's look at one where we maybe have the same original dollar amount. So let's find the value of 10,000 again. So let's do 7 3/4 year. So let's be really extra about it. And let's say it earns 4.5% interest compounded quarterly. So notice, instead of continuously, I mentioned a frequency, right? If I said quarterly or any other specific frequency, then we're not using the PERT formula anymore, we're using the other one. So we're going to use A equals P times 1 plus R over M to the MT power. That was the formula we had before. And we just need to decide what's what, right? So let's talk about it. So where does the 10,000 go into? Is the 10,000 the final investment or the original investment? Original, so that goes here. And then we have 1 plus, okay, so what's the interest rate? Not 4.5, but what? 0.045. Okay, so here's where you might need to think a little bit, right? So notice that we are quarterly. So I'm going to write this off to the side. If we are quarterly, then what would M be? M is 4, right? So if you said 3, I know what you're thinking. You're thinking every 3 months, but remember, M describes how many times a year it is, right? So how many times a year is it if it's quarterly? 4 times, right? Think of the seasons, right? There are 4 seasons, okay, that happen quarterly. So M is going to be 4. And then we will raise that to the 4 times what power? How am I going to write 7 3/4? Yeah, just 7.75. So make sure you're clear, but this is going to need to have parentheses if you have an older calculator. Okay, so that is 4 times 7.75. Okay, so there's like a times dot in between 4 and 7, and then a decimal place in the 7.75.
I think that's the homework one I was talking about before, where I was like, it wasn't a solid year.
Oh, yeah. So you just need to change it to whatever it is. And by the way, you could do that by using your calculator. You could do 3 divided by 4 in your calculator and you'll get 0.75. So if it's like a number of months that you don't know, or let's say it's 10 months or something, and you weren't sure what fraction that is, you just do 10 divided by 12, and it'll give you the decimal for that. Okay, so it'll tell you like what portion of the year that many months is. Okay, so let's punch this in our calculator again. If you have one, I want you to do it with me, because watching someone do it on this is not the same as doing it yourself. Okay, so you're going to do 10,000 times, and then I need to do an open parentheses. Okay, so it's 1 plus 0.045 divided by 4, close parentheses. Okay, remember, anything with more than one piece, you're going to need parentheses around it. So now I'm going to say to the power of, so that is this button if you're unaware. Okay, the button above the divided by sign if you have a TI is the raised to the power of. So it's going to be to the power of, and then I want to go 4 times 7.75. So if you have an older calculator at home, you'll just put parentheses around that 4 times 7.75. Okay, and we will get an answer that doesn't seem too wild and crazy, right? It's just an extra, I say just, I mean, I'd like just an extra $4,000, but it's not like 5 times bigger or something unreasonable. Okay, so what part of that is the interest you earned then, if this is your money? $4,145.38, right? So we always include the cents. It's really important that you do. So if you're dealing with someone's money, do you think they want you to chop off the cents and just round it to the nearest dollar? We don't want that, right? When we're at Walmart. So just make sure that you round it to the nearest 2 pennies, okay, or two decimal places. I mean. Okay, so that is quarterly. I don't want to do a full-blown other example, but I just want to remind you of some other words that you might see, because on your homework, it's going to give you different questions than your neighbor, okay? So if it's monthly, we already talked about this. What would M be? 12. If it's weekly, then it's going to be what for M? How many weeks in a year? 52? Okay, so if you don't know that, you need to kind of commit that to memory. If it's annually, then it's just going to be how many times a year? Once. If it's daily, it's going to be what? 365. And then I'm going to include this one just because a lot of people get paid this frequency. So there are a lot of people investing in like 401ks this regularly. What does bi-weekly mean? If you get paid bi-weekly, what does that mean? Every other week, right? So every 2 weeks, which means you can take the weeks and divide it by what? 2. So bi-weekly means 26. Okay? So there are more, like sometimes there's like semi-annual. Okay, I'm not going to include that one because I don't think that one's in any of the homework. But if you're like a shopper, what is a semi-annual sale? How many times a year? Twice a year, yeah. So you just need to know the terminology. So in other words, if I change this problem to be monthly, what's the only thing that would change in my calculation? The 4s would both change to what? 12s, right? And if I did daily, the 4s would both change to what? 365? Okay. Okay, so what you're going to find, and I want you to kind of write this down, because this is a principle of finance that you need to be aware of just in your own life. But the more frequently that interest is compounded, the more money is earned. By the way, compounding just basically means we are figuring the interest more frequently.